Okay. Am I actually recording? Yes, I am. All right. So let's talk about chapter 10. This one. Okay. Chapter 10. So this stuff you should already know. So like what special senses are, what somatic senses are, okay, what stimulus these concepts are, um, threshold, etc. Okay, so let's talk through. Okay. Um, okay, so let's talk through some of this stuff. Okay. So we'll talk like receptors are sensitive for particular forms of energy, like uh, chemical receptors are responding to chemistry. Um, like vision is through light, right? So like so the four major groups. Okay. Um, okay. So simple, more complex, even more complex. We'll be talking about this stuff most. The last thing, special senses. Okay. Okay. The simple receptors here just are really easy, right? So the stimulus comes in. Um, this one they have modified stimulus because they have an enclosed nerve ending, and therefore, so the stimulus needs to be a little bit stronger to stimulate the corpuscle. Okay, and then lastly, the this is how you really modify stimulus. You the receptor, the synapse has to work the same way as this thing right here, but you can put a cell on top of that absorbs whatever type of stimulus you're interested in receiving. Okay, next slide. The receptor, like this stuff you should know from anatomy, so make sure you understand this. Okay, so here's a couple different definitions that you need to know. Okay, what a threshold is, what adequate stimulus is, what what transduction is. Okay, transduction is moving from one sort of energy into another. Okay, so usually light, smell, some stimulus energy is converted into electrical signals by the nervous system. Okay. Um, okay. Okay. Um, more definitions that you have to understand. A receptive field. Okay. A neuron, every neuron has, or every sensory neuron has a particular receptive field. Some receptive fields are really large, some receptive fields are really small. Okay. And it depends on where you are. Okay. In the brain and in the body. Okay. All right. So the more sensitive areas, okay, have smaller receptive fields. The less sensitive areas have a larger receptive field. And the best way to demonstrate receptive fields is something called a two-point discrimination test. Okay, so what you do is you have 2 points. Okay, 2 points. Let me see me here. You should be able to. Okay. Yeah, 2 points. Okay, these 2 points, if I put them in different locations, I sense them as 2 points. But if I put them in very close locations, I sometimes feel it as 1 point. Okay, and so what you guys will be doing in one of your labs is something called a 2-point discrimination test. If you determine 2 touches from 1 touch. Okay, and where the sensitive areas on the body are. Okay. Okay. All right. So here you go. The receptive fields can be large or it can be small. Okay. Notice all 3 of these guys come in converge on the same secondary neuron. So no matter where you put your needle, all 3 will trigger the same response. So you'll feel it as one individual thing. You like here, you will not be able to distinguish between those 2 points. They'll feel like one thing is touching you. Okay, on this side, because they go through different secondary neurons, like this one goes through the green one, this one goes through the purple one. Okay, they will feel like 2 separate points. Okay, so something with a large receptive field, something with a small receptive field. Okay, now I'm sure they'll go over that in more detail in lab. Okay. Okay. So the CNS integrates sensory information. So visceral reflexes located in the brain or spinal cord usually don't rich conscious perception, like your stomach contractions and stuff like that. So we need to talk about something called threshold, right? The threshold is the level of stimulus necessary to be aware of a single particular sensation. So if I fire like in the dark, if I fire 1 neuron or 1 photon of light at your eye, that photon will activate, but it won't be enough to reach threshold. So you won't actually see anything. The same thing if I produce a very low wave sound, you won't be able to hear it. Okay. Okay. Habituation is decreased perception through inhibitory modulation. Okay. So your perception threshold changes. Okay. So if I put you in a room with really bright lights, okay, your inhibitory modulation will kind of dim everything eventually. And I all of a sudden turn off all the lights. Like I can leave a little light on and you still will perceive it very well. But once your body adjusts, the room will seem to get brighter. Like you'll be walking through a dark room and then your eyes will adjust and then you can start making out objects again. Okay. I'm sure all of you guys have gone through that before. Okay. Sensory. So, okay, so this stuff you should know already. Okay. Okay, so coding and processing distinguish stimulus properties. So sensory modality, which neurons are activated, and then which were the neurons terminated in the brain. The location of the stimulus. Okay, if there is any lateral inhibition or population coding or not, the intensity of the stimulus, and so how frequently they fire, the action potential, the duration of the action potential, and then last but not least, tonic receptors versus phasic receptors. Okay, so Okay. Um, the location of sound, again, is processing the stimulus through the left and right ears. So we hear things on the right. This difference is very, very slight, but our brain can detect it and our brain can use it to zoom in on where the sound is coming from. Okay, the sound is straight ahead of you if the two sounds going to the right and left ear are equal. Okay. All right. Okay, so if I take a pin and I shove that pin into your fingertip, uh, if you look at your finger, you're not only depressing the area where the pin is going in, you're depressing the area around it. Okay, and to get a sharp stimulus, and if you do this with your fingertip, this is particularly sharp stimulus. Okay, so what you want to do is this neuron that's firing not only wants to fire, but it also wants to inhibit the neurons around it. So the only signal you're getting is from this neuron, and therefore you feel it being sharper. Okay, there is more lateral inhibition, so the area you feel is more precise. Okay. Okay, how you code for stimulus intensity and duration. Okay, so here is the duration amplitude. So here you get a longer stimulus and a stronger stimulus. You get more firing of the action potentials, and more firing of the action potentials releases more neurotransmitter. More neurotransmitter equals stronger signal. Okay. Like pain works this way. Okay. Um, the pain adaptation, the same stimulus causes the same amount of pain. You just learn to ignore it. That's not You're not feeling less pain. You learn to live with it. Um, okay. uh, One of the things I want to make sure you understand is the difference between a tonic receptor and a phasic receptor. Okay, tonic receptors are slowly adapting receptors that respond for the duration of the stimulus. So no matter um, like your vision, uh, you can block it out, but you still see it. Uh, so tonic receptors are slowly adapting receptors that respond for the duration of the stimulus. Phasic receptors actively adapt to the constant stimulus and turn off. So phasic stimulus, think about what it means to wear your watch or your ring or whatever piece of jewelry. You probably can't feel that anymore. Like once you put on a ring for a while, you don't feel it anymore. But try taking it off, waiting a couple of minutes and putting it back on, and all of a sudden you'll feel it again. Okay, the phasic receptors. Okay, all right. Okay, the somatic senses: touch, proprioception, temperature, nociception. Okay, so the pathways project to the cortex and cerebellum. Okay, the receptors are located in skin and viscera. Okay, there's three levels of neurons: so primary, secondary, and tertiary. Okay, um, okay. The primary neurons, synapses, CAS, and secondary sensory neurons. Okay, uh, and then the secondary neurons are interneurons in the CNS. Okay, interneurons always will stay in the CNS. So they're going to go to the thalamus, and then it goes from the thalamus to where it's supposed to go. Okay, so somatosensory cortex for cerebellum. Okay, so here, primary sensory neurons go to the spinal cord, and the fine touch vibration goes all the way to the medulla. But the second sensory pathways always go to the thalamus. Okay, the only exception to that rule is your sense of smell. Everything else goes to the thalamus and then goes to wherever they're supposed to go. Okay. So this is your somatosensory cortex. Okay, so you can see this thing is called your motor homunculus, but somatosensory homunculus. Okay, you can see like different regions of your brain are bigger than other regions. Like the region controlling your hands and fingers are much larger than your hand is larger than your entire body. There's more sensory receptors going to your head than your entire trunk. Okay. All right. So I'll explain this one on the next slide. Okay. All right. So there are different types of receptors. Okay. Different types of receptors will receive different types of information. Okay. Free nerve endings are nociceptor. Okay. Responses of pain. Merkel receptors sense steady pressure and texture. Mesner's corpuscles respond to flutter, stroking movements along the surface of the skin. See how close to the surface these things are. So they actually respond to very sensitive things on the surface. The Pacini corpuscle and the Ruffini corpuscle. Okay, these guys are deeper and they're not nearly as sensitive. So this is Pacini corpuscle senses vibration, or better explained as deep pressure. Ruffini corpuscle is stretching of not the epidermis but the dermal layers. Okay. Okay. Skin temperature receptors are free nerve endings. Okay. So cold receptors are anything lower than body temperature, but too cold actually activates pain receptors. Pain receptors are activated, I think, below 4 degrees and above 45 degrees. So anything feel that, you're not only feeling cold, you're also feeling pain. Okay. Okay. So you don't have to know this chart. You don't have to know what those receptors are, but you don't have to know anything else like alpha, delta fibers, and C fibers, etc. Okay. Okay. So pain is a subjective perception. Okay. So the fibers are firing, but how you tend to interpret it is different. So that's the subjective part. Okay. The fast pain is sharply localized. Okay, these are near the surface, like your muscles, and in the somatic nervous system, parts that you consciously control. So the pain is very sharp. The duller pain is by C fibers. C fibers are what's activated if you have a stomach ache. The pain is not like sharp, it is kind of diffuse, like your whole kind of aching, gnawing feeling, but not sharp pain like being punched in the arm. Okay. Okay. So, okay. Um, okay. I'm gonna shortcut this a little bit here. Um, okay. I want to make sure you understand these two things: recurrent pain and chronic pain. Okay. Recurrent pain is usually internal. Okay, and pain in internal organs in your viscera. You're so not used to having pain in your viscera that your body is not making any sense of it. Okay, and so what happens is it chooses so you have tracks that go from any organ back to the brain, and so it chooses somewhere in the same tract and go, oh, okay, it must be that it must be it's going up the same track, so it must be this thing instead. Okay, because they're traveling in the same tract. So they go up the same track. So okay, uh so they must be instead of being kidney pain, it must be usually that. Okay. All right. Um I think I'll explain the pain modulation in the next chapter or next recording. So I'll end this recording right here.